Infinity, convergence of infinity series. Okay, let's see the definition of infinity series. It's a description operation of many terms. And for example, these are the infinity series from 1 to infinity, and you have many applications in engineering, physics, computer science, finance, math. For a given sequence of a number like this, and this is the way you find the final limit of the infinity series by doing the partial sum. So, and take the limit from n to infinity. This is how you find the sum of an infinity series. And infinity sequence is said to be converge if partially sum is going to limit. If it's going to infinity, it's called diverge, or oscillate either finite or infinity is called diverge. And if it is converge, it goes to a limited sum. These are the example of the infinity, how to find the sum of the infinity series. These are one of example. You do this and you find the limit x going to 1 for this series. And another example is geometric series like this, and you find the partial sum Sn is equal to this, and you take the limit, and you find is the infinity series sum is like this. And in this case is diverge when absolute k is greater or equal to 1, and is oscillate either finite k equal to -1 or infinity k less than -1. And okay, so if k absolutely less than 1 is converge. Now these are the application example. For example, Kerry is training for marathon, is running heavy each day, and so the total distance it run is like this. And one simple way of doing this is a half, quarter, 1/8, 1/16, and you can see the infinity sum is equal to 1, something like this. And there are many different kinds of infinity series: geometric, arithmetic series, harmonic alternative series, and power series. And these are some of the examples. Okay, these are another way of looking at that previous example. You can do the partial sum, and you can use graph, and you can see it's eventually it will converge to 1. Another way of looking at this is just calculate the partial sum and take the limit n to infinity, and you can see it's also equal to 1. Now I'll give you some example of this arithmetic series. Is definition like this, and these are some of the example, and I will show you how they come up with this formula. And geometric series like this, and if it is in this range, it will equal to this. So let's see how they come up with this. Finite arithmetic series is actually derived by this, and you add them together just like this, and you can get the formula. For the geometric series, you can the partial sum Sn is equal like this, and you multiply by q, and you add them together, and you can come up with the formula. And these are the example. Zeno paradox is just a way of, it's not really a paradox, it's just a way of doing the geometry theory. And I will give you example. Zeno paradox is like people is running and compete with turtle, and this will show you it's just according to this formula, it says impossible how Achilles will catch up with turtle, but it's actually it can, and it's just a way of calculate the geometric theory. And these are another example, bouncing ball distance and pendulum swimming. So you can take a look at it. Some other easy way of looking at this is partials, getting the partial sum like this. You just n here, n plus 1 here, and you more is half. So that's one way. And you can see in this theory, you can do it this way, and you can see when you take the limit n to infinity, it actually become infinity, so it's diverged. And this power theory, actually, it should supposed to be p supposed to be greater than -1 and less than 1. This is right. If you are plugging p equal to 2, you actually get -1. That's not right. There are some other theory. I will give you a whole bunch of theory for your information. This arithmetic geometry theory, power of positive term, and you can see is a Bernoulli number. And I will give you some example and some power theory like this. And these are reciprocal of powers of positive integral. And I will show you how they come up with log 2, and this infinity theory to be pi divided by 4 later. And these are some other interesting infinity theory, and these are some other, and these are the formula for your information. These are definition of Bernoulli number and the Euro number for your information. And these are some values and relationship with, and these are that give you some theory in both Bernoulli and Euro numbers. Taylor series, just give you some example. Taylor series is also very important. These are just give you information about Taylor series. This binomial theory, and you can see it's all listed here for your information. And theory for exponential and logarithm functions, and these are all very important.